Seeing that the US has just celebrated its Independence Day this week, and by the way, if you're celebrating, hope that you had an absolutely smashing 4th of July. A bit late now, but yeah, that brings me to the main project we'll be working on today, a flag to ASCII generator. So this is part of a new beginner series focused on OpenCV and doing fun, small projects with OpenCV. OpenCV is the de facto library for computer vision tasks, and throughout the series, we'll build some mini projects and acquire some familiarity with OpenCV in the process. Now, it's not strictly a computer vision class though. For that, I have another playlist called the Computer Vision Essentials that I will slowly develop on this channel. This playlist is different from that. This playlist is going to be less theory and it's going to be more I think in fact almost no theory. Is going to be more project-based learning and exercises, starting with building an image-to-ASCII generator, and we find new ideas along the way. So what are we going to create today? We create a Python program that takes an image and generate the corresponding ASCII characters so we can use them in our email signatures, in our GitHub README, in our CLI applications, even in text editors like Microsoft Word or Notepad, since the image are really represented as ASCII characters and symbols anyway. So it's not a complicated project, but it does teach you how to think about image as an ND array, which is short for n-dimensional array, and how to manipulate the array from raw pixel numbers to a transform representation, and in our case, symbols that form our image. So to stick to the Independence Day theme, we use a bunch of national flag images, and hopefully it'll be a fun exercise and a gentle introduction into OpenCV. So if you're new here, I'm Samuel, and on this channel, I create project-based tutorials teaching you how to code by building mini projects that hopefully make learning a little bit more fun, a little bit less abstract. So okay, let's get started. Okay, to start you off, I'm currently in my desktop, so print working directory, I'm in my desktop. I could create a new directory here. You could create this in your Dropbox anywhere you want, okay? I'm gonna go ahead and create a new directory, and I'm gonna call it ASCII file. So I'm gonna say ASCII file, so that's kind of like ASCII and then ASCII file an image, right? Take an image and you turn that into an ASCII representation of that. I mean, you can name it anything you want, all right? So I'm gonna just do that, and I'm gonna change directory into that. So I'm gonna say ASCII file. So that's gonna say make directory, name it ASCII file. If that is successful, then change directory into ASCII file. So let me do that, and now that I'm in there, let's create a new virtual environment. So you can use venv, you can make new virtual environment, you can do it any way you do it normally, right? For me, I'm already in my virtual environment, so I'm not going to do that. So I'm just going to go ahead and install the libraries. So you can go ahead and do something like pip install numpy. That's the first one you want to install. Numpy is one of the dependency. The second dependency is OpenCV. So you want to say OpenCV Python. So pip install numpy and pip install OpenCV-Python. So let me hit on that. It's going to say requirement already satisfied because I already have that. So it's not going to do anything. But for you, you may have to give it about 1, 2 minutes to 3 minutes. So pause the video, wait for that to complete. So again, the instructions are pip install numpy, that to install numpy as a dependency, and then you want to say pip install OpenCV-Python. And once that's done, you want to go on to your browser, open up a browser, go and download some images of some country flags or whatever you want. Okay, I'm going to use country flags because first of all, it keeps to the theme of the Independence Day, but also because they're going to be relatively similar in sizes, so I can when it comes to coding, it becomes easier to just code a certain dimension and know that to be true, because flags are usually going to be somewhat rectangular in the shape, and they're going to have very similar dimensions, whichever flag you download from the internet, right? So if I show you my tree now, okay, if I print out tree, I have one directory, it's called assets. So that's one directory, and then it says 10 files in there. So I have Indonesia, Japan, Korea, Malaysia, North Korea, Rising Star, Singapore, Texas, United Kingdoms, that's the Great Britain flag, and then US. So obviously Texas is not really a country, and Rising Star is also not a country, but just to show a little bit of variety in there. And so up to you, go find some images. If you're from Philippines, go and use Philippines. If you're from Mexico, use Mexico. What have you, right? So I'm gonna have this 10 files. That's good enough. So if you want to pause the video a little bit now, go and create a folder called assets and go and download some images. If you don't want to do that, I'm gonna leave a link to my GitHub repository. You can also just go to my GitHub and just click on download, and you get the whole assets directory, including all of the files of the images in there. All right. And now what we can do, you want to make sure that your OpenCV is installed, your NumPy is installed. So now you can go ahead and just launch your Python, right? So now I'm going to clear my screen, just Control L cleans up all of the screen, and you can just to test it out and see if this whole thing works as you expect. So go ahead and just import CV2, that's computer vision. C stands for computer, V stands for computer vision, and this is the second version of that. So let's go ahead and try a couple of things, right? Now the first thing is to try and read the image in there. So let me just show you where my current directory is. So I'm going to say os.get current working directory. Okay, I'm currently in ASCII file already, so I don't need to know that. I don't need to import OS. If you know where you're at, you don't have to do this at all, right? So the first thing you need to do is to just say import CV2, and then now let's go ahead and read our image in there. So I'm gonna just create a path, and in my path, it's gonna be within this. I'm gonna say assets, and I'm gonna say gb.png because that's Great Britain, and then I'm gonna say image equals to cv2.imread. Im stands for image, so image read path 0. Okay, I'm gonna explain what that 0 does, but let me just make sure. Okay, so that's because I didn't name it GB, I named it UK, right? So let's do that, and then I'm gonna just say image cv2.imread. Okay, now it works. All right, so you want to name it correctly, and if you don't know what to do, you can open up a sort of and just change that and just say ASCII file, and then you can just print the tree, and you can take a look at it and just have that as a reference. If you want to sort of have a reference, you can just split your terminal and do that. I'm using Kitty, by the way, but I'm sure a lot of the newish terminal emulation they could do this, right? So I'm just gonna close that out now. Now, what you realize is a very common, what you realize here, what you see me do here is actually a very common routine in computer vision images. So when you first read import CV2, so you do something like import CV2, and the next thing you do is you specify a path to your image or a path to where all the images are, and then you can run a for loop on it or something. And then what happens is that you would do something like cv2.imread, and then you pass in the path, because usually when you want to work with computer images, you kind of can't do anything until the image is read in there anyway, right? So you want to say imread path. So if I show you img shape now, let's see what happens. Now I have a dimension here. What's really important to understand here is that the first value here, this refers to the height of the image, this refers to the width of the image. So 159 being the number of rows in a way, right? The number of rows in a, just imagine this image being a 159 times 318 matrix, and then each grid in that, each value in the matrix is actually an RGB pixel, right? So just imagine it that way. So 159, that's the height, 318, that's the width. You don't want to mistake them, because it's very easy to be confused here and think that, oh, 159 refers to the width, because a lot of times when you come from a computer vision background, you always expect that, okay, the first value is the width, then the second value is the height. But in OpenCV, the first value refers to the height, which is the number of rows, and then the width, the number of columns, right? So here it's saying that this image is actually wider than it is tall, right? So 159 height, 318 width. And then why do you need to pass in a 0? So let's see what happens if I don't pass in a 0. Okay, if I do this and then I say image.shape. Now what do I have here? Now I have a 159.318 tree. So what does that tree actually do now? So the tree actually basically is still the same thing. There's still the matrix 159.318, except each one of those pixels now have the RGB, right? The RGB, the red, the green, the blue. So these are 3 channels, right? So that is also going to be a problem, because we don't actually plan on using all the 3 values. We just want to have 2. So we could you don't actually need to have 3 channels, so you want to specify a 0. Okay. If you actually want the RGB, you want to pass in 1 instead. And now if you look at if I just print out the img, you see that there are 3 values. So you see that there is the R, the G, the B. Except that in OpenCV, you actually have the BGR instead, so you have to flip them, or you can use one of the utility functions, BGR to RGB. We'll talk about that in future videos, but for now, don't worry about that. All I want to show you is that if you print out the image right now, you see that all of them, right, there is the represented the 3 channels, which is the red, the green, the blue, all right? And if you, let me clear up all my screen now. If you don't pass anything, and if you print out img, you're gonna see the same thing here, right? So let's clean up all of that. So what we actually want is to pass in a 0. So the second argument being 0, this is going to read the image as an 8-bit depth grayscale image. So what I mean by grayscale image is that you realize that there is no RGB, there's only one value, and that is the grayscale value. So this is going to be 0 to 255. So in total, the range of values go from 0 to 255, all right? So each of the value in this matrix would just be a value between 0 and 255. It wouldn't be an array of 3. It would just be one scalar value, all right? So you're getting a value from 0 to 255 as color for each pixel of your image. And now let's go ahead and make sure we don't make any mistake by putting height width equals to image.shape. So this is going to unpack the value. Image.shape is a tuple. So the first value of the tuple is going to be the height. The second is the width. So again, don't mess them up, because a lot of times this is very commonly confused. You see people trying to specify width and then comma height equals to image.shape, and it's going to mess it up. So don't want to do that. So now we have the height, and now we have the width. All right. And then what we can do next is we can think about how do we want to take this and reshape them a little bit, because you don't want to have a whole, what if the image is 3000 pixels wide? Then now it's going to take up too much of your terminal, and it's going to be squashed. It's going to go into a new line. It's going to look really ugly. So in a way, I want to basically shrink this down a little bit. This whole operation is called resizing, right? So I want to resize them a little bit. So what would be the new height and what would be the new width? Now, it's up to you how you want to define this. You can play around with these figures, but for me, what I found to be good was something like divide the do a floor division of the height and do a floor division on the width. So I like to put in something like new height equals to height and floor division of 8. So that basically dividing by 8 and then take the floor value of that. So that this is the same, right? This is the same, by the way, as taking something like take the integer and take the height divided by 8. This is the same, right? So you say take the 8 and then just take the integer value of that. So I'm going to say that, and of course I'm going to do the same thing for the width. So I'm going to say width, oops, and here I'm also going to replace that and say width, just like this. But I don't want to divide by 8. I want to divide, let's say, by 3, because the width itself, I want to sort of keep some of the proportion there. So I want to say something like 3. Obviously, you can go and tinker around with the values and try and get something that looks good for you, right? And then what you need to do next is to take the original image, which is 159.318, take that original image and transform them, resize them into a new image. So what you can do is you can say something like resize image. So you can say resize image, and you can use a utility function in CV2 called resize. So CV2.resize, and resize takes a few parameters, but the first one is take the original image, and then it takes a tuple containing the new sort of dimensions. Now in this new dimension, you want to be careful, because now it's not about the height and width anymore. You want to put the width and then the height. So you want to say new width, and you want to put a comma, you want to say new height, right? So I know this is getting very confusing, because initially you would have the height first and then the width later, but now you said the width and then the height. So what you need to remember here is that in when it comes to OpenCV, when you take an image, this image is always represented as a matrix, and so it's common to think of it from, you know, from a row perspective. You'll say that the height and then the width, right? So because the number of rows, which is the height, and then the number of columns, which is the width, which is very, very common in data analysis. We usually refer to the row first before we refer to the column. So that's how you sort of remember. That's how I remember it, right? Is that I always think of it like, okay, in numerical computing, we always think about the row first, and then we think about the column. We specify the row first. So that's kind of how I know that it's going to be height first and then width. But then when it comes to CV2, you will in a computer vision domain, it's more common to refer to it the width first before the height. So that's how that's how I sort of wrap my head around this. And I'm just gonna say enter just to create the resized image. And now you could go ahead and just say cv2.imshow and just show the whole thing. So I could say something like cv2.imshow and I could show it. But I won't do that now, because when you do an imshow, so what I mean by this is I'm gonna say something like imshow. Oops, accidentally put on the caps key, and you would have a simple title for the window. So you can say something like resize image, and then you have your resize image. And if you hit enter, you're gonna get that window popping up showing you the new rescaled resize image. I'm not gonna do that, because when I do this, I typically want to call it along with the cv2.wait key. So that's gonna wait for a key. If I hit on the key, it just closes the window, right? Otherwise, it's gonna crash or hang the sort of the window itself. So in order to show you how all of this is done, I'm gonna quit out of Python now, and I'm gonna just go back to my desktop, and I'm gonna say ASCII, and then what I'm gonna do, I'm gonna still make sure I'm in the right environment. What I'm gonna do is that I'm gonna open up code, and to do all of this in a nice keeping things modular, keeping things tidy and organized in the Visual Studio Code, writing them in their own function and stuff. But that's essentially the same stuff that I'm gonna repeat. I'm just gonna copy this code, put them into Visual Studio Code. So you can open that up using code dot. And code dot is basically current working directory. So you're saying open up Visual Studio Code in the current working directory. So that's what I'm doing. Let's do that, and then let's move over to Visual Studio Code now. Okay, now that we have Visual Studio Code open, we can get started developing our script. Let's go ahead and just create a new file. So Control N, and then you want to say Control S to save the file. You can name it. I'm gonna just name it ASCII as well. So I'm gonna just type that in. ASCII.py. I'm gonna save that. So now I have a file called ASCII.py, and then I have my SS folder, which is in there, and within it I have all of my flag images. Again, all of this is going to be on my GitHub, but you could feel free to use any images you can find, download them into your local computer. Now again, all of my, now again, all of this, now again, all of the images of these assets are all on my GitHub. If you want to just go ahead to go to the GitHub URL. Now again, all of the GitHub, now again, all of my assets, the images, all of those things are gonna be on my GitHub. So if you want to, you could absolutely just go there and just grab it from the GitHub. Just do a git clone if you want to. If not, just go ahead and just find some images, flag images, download them, put them in a folder, call them assets, and that's it. All right. So now that we have ASCII file.py, we have that open up. It's just gonna be a blank file right now. So let's go ahead and do what we have already done in our terminal. So you can open up a terminal, put them side by side, and you can just sort of compare to what you've written already, but they are relatively straightforward anyway. So I'm just gonna go ahead and just do the same thing, import CV2, and I'm gonna also need numpy. And the reason we need numpy is because OpenCV under the hood, it's really what it's trying to do is to just import, just bring in the image and then really represent them using a numpy array anyway. So we need numpy to sort of do those kind of numpy array manipulation. So might as well just bring that in. All right. So OpenCV, when it brings an image in, when you read an image in there, it's really trying to read it as a matrix, and within a matrix as an ND array. Within the ND array itself, remember how we say that each of the pixel, if you read them in as a RGB, then you have a channel of 3, you have an array of 3 for each one of those pixels, right? So one pixel is contain a array of 3, so that's the red value, green value, and the blue value. All right, so each one of them will be 0 to 255. If you read them in as a grayscale, then you don't have a vector of 3. What you don't have a array of 3. What you have instead is a scalar, so a grayscale value, 0 to 255. All right, so now that we have the two of them, let's go ahead and just bring in what we've written in our code. Okay, so it seems like the first thing we do is to read the image in there anyway. So let's go ahead and say if name equals to main. So if we run this as a main script, not import this file to something else, but let's just read if we import that right away, then we want to basically read it in, right? So we want to say image equals to cv2.imread, and here we pass in a path and we pass in 0. We already explained why it's 0 because we want it to be grayscale, but we need a path. So let's go ahead and say path. Okay, now path, I'm just currently gonna hard code a value right there. So I'm gonna just say something like read it from my assets, and I'm gonna say something like assets, and that's this one. And then I think it's gonna just be uk.png, right? So that's just gonna be uk.png. And later on, we're gonna find ways to, maybe we can bring in arc parse or something to sort of like allow somebody to specify what is the path they want. But right now, let's just keep it that way. And then immediately what I want to do next is I want to basically create this generator. So I'm gonna call it define, and I want to call it generate ASCII. So I want to say generate ASCII, and it's gonna basically take something, maybe take an image and do something to that image. Okay, so it's just return an image right now. But here, what we want to do is to basically say ASCII art, and we want to say generate ASCII, and want to pass in an image. Now let's go back and do generate ASCII. What do we want to, here? So remember how we just did the whole width and shape and all of those things? So we're gonna do the same, do very similar things here. So I want to say height and width. That's just gonna be the image shape. So we're just gonna do the tuple unpacking, because image.shape is gonna return a tuple of 2, and the first value is gonna be height. The second value is gonna correspond to the width. So image.shape. And then what we did earlier? So if you look at the code again, you see that what we did was we tried to do some sort of resizing. So new height divided by floor division of 8, new width division of 3. So I'm just gonna copy pretty much the same thing. I'm gonna say new height, and that's just gonna be height, floor division of 8, and then I'm gonna just copy that down, and I'm gonna say 3, and here I'm gonna say width, and here I'm gonna say width. Okay, and what else do we have here? We said resize image cv2.resize. So I want to do the same thing pretty much again. So I'm gonna add a comment here just to be tidy. I'm gonna say this is just resizing image to fit it in a console, to fit in console for printing, right? Because otherwise, what if the image is huge? If the image is huge, it's gonna just wrap around the console. It's not gonna look nice. Anyway, would it, right? So we're gonna say resize image, and I want to say that is just gonna be cv2.resize. So resize doesn't actually take the old image at all. It doesn't take the height and width. What it takes is the new width and new height after you specify the original image. So I want to say image, and now I want to say new width, and want to comma new height. So this is going to be a tuple of 2 as well. So that's going to be the new image. And now you can finally go ahead and use your cv2.imshow. So if you want to, you could say something like using the CV2 to sort of display the image, and wait for user to press any key to shut it down, right? To close down to close it down, so prevent the Python kernel from hanging, right? So let's go ahead and say cv2.imshow. What do we want to show? Want to just show the resize image. So say resize image. I want to put a comma and then want to put resize image. And then you want to say wait key, and just put 0 here. So this is kind of just waiting for any key press to be done. So let's go up, open up a terminal, and I'm going to clear my screen here. And I could go ahead and just say Python ascii.py, and just gonna put nothing in there. And let's see, hit enter. That's because we forgot a dot here. A dot basically says the current working directory. So let's run that again. Okay, now it's opening. All right. So this is always going to be a relative path unless you want to specify the whole, maybe like something like user / Samuel / desktop / something. You want to put in the absolute path, you can, but I'm just going to use a relative path. So that's why I'm putting a dot, which says the current working directory, which is this directory. Go into the assets folder and look for uk.png. And then what's going to happen is that when I run that code now, IamShow is going to be kicked off. IAM stands for image. So IamShow is kind of a way to say display an image in show the image. So IamShow, IAM image show, and this is the name of the window. So here we have resize image. I don't think you're going to see it here, but the window is going to be called resize image. And then here is what you want to show. And then you're just going to wait for a key. So if you hit a key now, close the, you can sort of close the window. So let's try that again. Run that, hit that, you see it coming up again. And if I hit any key, maybe hit escape button, it would go off, right? Let's try another one. Let's try this time. Let's try something like Singapore. Let's try Singapore. Run that. Okay, Singapore comes up, and then if we close it, it's gonna close it out, right? So very quickly we can take a look and see if we want to change things a little bit. Maybe we want to change the height to be 6. I think. Let's try that. This is fine. All right. So let's maybe keep to 6 right now, and you can just sort of play around with that. We're gonna maybe try one more. Try us.png, and okay, this is how US looks like after the grayscale. Okay, so this is cool. So what happened is that OpenCV actually tried to read them in. When you call it here, IamRead, it reads it as a grayscale, meaning each of this value, each of this black and white that you see here, each of them, if I hover over, you see that these are the coordinates. I know it's a little bit small. Let me actually maybe make it a little bit bigger. You see that there's a x equals to 91, y equals to 15, x equals to 81, y equals to 10. Now each one of those, they actually point to a certain value, and that the pixel itself, there's a value, and the value would be something between 0 to 255. All right, and then what we did is we shrink it down by a certain proportion. Here it's like take the height divided by 6, take the width divided by 3, and then what we do is that we later resize them, and then we show them again, and this is what you see. So when you what OpenCV actually does is that it provides you all these facilities for you to sort of take a NumPy array and ND array, display them, and then take the image and then re-represent them back into the ND array, because every image, every single image out there technically is just a matrix of a grid of, if you want to think of it, a grid or matrix of pixels, right? Basically just values that give them the color, give them meaning. What is the red, what's the green, what's the blue, and that's really what makes up an image. All right, so let's close that out now. We just have to hit Q or click escape, quit out the window, and let's continue building on the script. Okay, so this is not really interesting. This is not really what we want to do anyway. The whole IamShow, the whole wait key stuff, it's cool. We get to see the images, but it's really not what we're doing with this project anyway. So you could either just comment out the 2 lines and just delete them, or you could just sort of just take out the whole thing as well, right? It's just there to sort of show you what what's OpenCV really is when it comes to dealing with images and converting them to NumPy arrays and stuff, right? So what we want to do is we want to take all of the pixels, all of these numbers. So think of it as a big matrix, right? Think of it like a matrix of numbers. So let's say this is an image, and you can think of it like this. And if this is an RGB image, meaning red, green, blue image, then you have some numbers. So you have like 170, 23, 21, and then 0, and then 105, and then here you have 255, 255, 255, for example. Okay. And really what you have is basically each one of them, a computer can look at this number and determine what kind of color that would be, because this is the RGB value. So okay, this is kind of a cyan color, a purple color, a gray color, and it can decide that, and it would then add that color. So a computer would know by just by looking at the numbers what to render for that one particular pixel. And if you have that across like 3000 pixels, then it forms an image, right? So that's really what it is. But what we want to do is we want to take all of these numbers and we want to convert them into something of this sort. We want to take all of this and we want to perform some sort of transformation so that they don't look like this, but they look like so actually they're not going to be RGB anyway, they're just going to be one number anyway. But we want to take all of this and we want to give them a symbol. So we want this to be like a plus, we want this to be a plus, we want this to be a dot, for example. We want it to be like that because that's really what an ASCII art is. So ASCII basically characters on a keyboard you can find on the keyboard. We want to represent them using these ASCII characters, and so we want to convert this into that. And the way we do that is to first specify a predefined list of all the symbols that we want to be using. So let's go ahead and do that, right? So let's go all the way up to the top of the script, and we're gonna just create a constant called symbols, and we're gonna give it a few symbols. So I can have like a dot, I could have like I don't know, maybe a minus, maybe a plus, so maybe have a plus, and then I could have like a multiply, the asterisk, I could have the asterisk, I could, another very common one is a pound sign, this hashtag, this pound sign is also very common, and O is also pretty common. So you can create a list of symbols, and you can have many of them, you can have 4 or 5 of them, 6 or 7 of them. I'm just gonna keep to like 6 because flags are not that complicated anyway, they don't really need that many, but if you want to, feel free to go and experiment with, you know, trying different values, alright? And then what we're going to do is we're going to also create a set of thresholds. So we're going to say thresholds. And then what we're going to do in thresholds is just set some values up here. We can tune those values later. We can maybe fine tune them a little bit. But now I'm just going to go increment by 50. But obviously later, if things doesn't look good, I'm going to go and change them up. I can have 250 if I want to, right? But maybe let's just stick to 200. If it doesn't look good, we can add 250 to it. And so what we're going to do is we're going to say for each one of the pixel, we're going to compare and say if the pixel value, because remember, they're just going to be a scalar value. They're just going to be a value between 0 to 255. And if the value is about, let's say 64, then it would pass this threshold, it would pass this threshold. And so now, but it doesn't pass this threshold. So we're going to replace it with this color, for example. All right. So that's kind of what we're going to be doing. So I guess in that case, let's just add 250. It doesn't matter, right? So then it has a nice corresponding value for each one of them. So if it's 251, for example, then it's going to be an O, right? So it's something that you can do by using a for loop and just sort of compare that. So let's go ahead and try and see how do we think about this. So I want to first create a placeholder matrix that looks like 0, 0, 0 everywhere. And then I want to copy this a couple of times. I want to just have, let's say this is my image, right? Then I want to replace this, the original image. I want to convert the original image into some sort of like, this becomes a number like 50, this become a number like 100, this become a number like 200 or whatever. So there are a few approaches you can do that. One is to sort of round them into the nearest 50. That's one way to do it, and then you can just basically replace them by symbols. Or another way to do that is just replace them by the sort of the index at which they are at. So 200 would be index number 0, 1, 2, 3, 4. So this would just be 4, this would be 1, and this would be 0, 1, 2. This would be 2. And so later on, you can just sort of in place replace them by the symbols. You can also do that. There's a lot of ways to think about this. But if you want to use this approach of like replacing them with the index, then you can use the for loop and then add an enumerate. So what I mean by that is that if I open up Python right now and I have like so let's say I have letters, and letters I'm just gonna have A, B, C, right? I could say something like for I in letters, and I can say print letters or print I, and they're just gonna print A, B, C, right? But what I can also do is I can say something like for I, and I can say something like for I, and then I can put a comma, and I can then put the letter itself. So for I letter in letters, but here I need to wrap them into enumerate. So enumerate, all right, like this, and then I can now print I, and I can also print letter, just to show you what it looks like. Now you see that I itself is, when you go to enumerate, what it does is that it first find, okay, the index, the first time it runs that is going to be 0. So it's going to say 0, and then it's going to print letter, which is A. And then the second time it runs the loop, now I is going to be incremented to 1. So I is now going to be 1, letter is going to now be B. And then now it's going to be incremented again, so I is going to be incremented to 2, and letter is going to be C. So that's what we're going to be using right here. So I'm going to go ahead and say for I, and I'm going to put a threshold in enumerate, and then now I'm going to enumerate over thresholds. So this is capital, so I want to spell that correctly. And then what I'm going to do is that for each one of the once you enumerate, as you step through each one of them, you want to compare and see whether or not the threshold image basically exceed that or not. All right, if it exceed, then replace it with the I itself. So if it's exceed 100, then it will be replaced with 2. If it exceeds 200, it'll be replaced with 0, 1, 2, 3, 4. It will be replaced with 4. All right. So let's create a placeholder. Let's create the something that holds all the 0. How do you create a matrix of all the zeros? Well, it turns out NumPy, which we brings in up here, allows us to do that really simply. And the way to create a matrix of all the zeros is basically np.zeros. So let's go ahead and say threshold image. Let's initialize that. So threshold image, and that's basically numpy.zeros. And numpy zeros is just going to create initialize all of this to be 0. So all it needs is basically a size. So for example, I could pass this in. If I want to create this one, I would have a 4 times 5, right? So this will create a 4 with the 4 of them, but then within each one of them, it will be 5. So that's kind of how I do it. But I don't want to hard code that. Instead, I want to use the resize image shape. So I want to say resize image, which is right from up here, and I want to say dot shape, right? So this is threshold image, and it basically create a matrix of all the zeros, basically a NumPy array of all the zeros within that. And you don't want to hard code the value, okay? You want to actually say resize shape because you want to be able to run across all the images. So you don't want to have like, if I just hard code the image, if I could just gonna hard code the value, it's gonna work for us.png, but it's not gonna work for North Korea, for example, right? So you don't wanna hard code any value if you can avoid that. So threshold image, that's kind of good. Now we just have to make the comparison. So we say what threshold image, and we say look at the value itself, look at that exact value, and see whether or not that value have exceeded that or not. So we want to say take the resize image, take this, and see whether you have exceeded. Whether you've exceeded what? Whether you've exceeded the threshold. So remember, we're stepping through each one of them. So it's first going to compare whether it exceeds 0. Of course, it's going to exceed 0 because at the very base form, the minimum value of that would be 0, right? So then it says, does it exceed 0? If it exceeds 0, then pass in the value of 0. Then if it exceeds value of 50, then pass in the value of 1. 100, pass in the value of 2, so on and so forth. So want to say, does it exceed the threshold? If it does, then what do? Assign that to the enumerate this I itself, which is basically the 1 or the 2 or the 3, and that's kind of it. So once you've done that, you can just return trash image, and let's go ahead now. Yeah, let's go ahead and just run that first, and I could print this ASCII out to show you what I have now, right? So if I quit this out and I run that again, you see that now I have all of my 0, 1, 2, 3, 4, 5. So this is perfect because it has 0, 1, 2, 3, 4, 5. All right, so that's perfect. If you wanna, right now what I see is that all of this is just gonna be a float. You see that 1 point something, 5 point something. So this is there's a decimal point there. So how do you take away the decimal point? You could just add an S type, and you say S type as what? As integer. If we save that and run that again, now you see that now this is perfect. The 0, 0, 1, 2, 3. This is easy for me to then later on refer here. All right. And that's kind of it. So now that you have this, what you want to do is you substitute all of them into the symbols itself. So you've already done the hard part. Now it's the easier part, is to just basically take each one of them and to substitute them with the corresponding symbol. All right. So let's go ahead now and create the symbol up here. And the way you create a symbol is you basically want to fill the each of these numbers here in place, fill them with the symbol. So actually let's add some comments. Right, let's add some comments, dot strings, to sort of remind ourselves what we're doing here. This is basically just returns the numeric coded image, right? So we want to create another one. We want to say this one, since we're just replacing, we're just printing out the symbols anyway, we're just going to call it print symbols. Okay, print symbols. And we want to say, we take an array and we want to return the array. But before we return the array, we want to have the dot string. So let's do that. And what do we want here? We want to say this is basically filling the symbols in place of numbers or index. Okay, so that's kind of what we want to do. So how do you go ahead and do this? So you can say something like for row in. So here, remember, this is what we're looking at, right? We want to say that for each of the row. So we want to say for row in array. Then within each of the row, so this is one row. One row is 005 ... 111. That's one row. Now within each of the row, what do we want to do? We want to go into the index itself. So you could say something like for I in the row itself. So the first one goes through each one of the row, then the second one goes into the row, and then look at each of the number, each of the pixel, each of the sort of the index within the row itself. And then what we can do now is we can say something like print. And what do we want to print here? We want to print the symbols finding the right index of that. So that's basically I. And then you want to think about a situation here. What if the threshold is not, so right now there's 6, so this is perfect because whatever it is, it would always find something in threshold. But what if this one is something like, or what if this one is only 5, for example? Now you need to sort of wrap around, right? And you can use the modular operator for that. So you can say take the I, and if the I divided by symbols, if the symbols, there are the 6 of them, then take the remainder of that and then just fill it. So you can use a modular operator. You can say take that, and you can say take the length of symbols. But now it's gonna be computing this for each one of the internal for loop. So this is gonna be computationally heavy. So what I like to do when I do this is I generally bring that out and I just say create something called length symbols and pass this in and just divide it by, just do this. So the reason I do that is that I don't have to then recompute the length of symbols. I know it's not a massive operation, but it's just kind of like it's efficient to not have to recompute that anyway. So just compute it once, save it to length of symbols, and then just use the same value instead of recomputing that within the nested for loop, which is probably not nice, right? So to bring down the complexity level. And then now we want to say and, so you don't want to, at the end of the print, you don't want to add anything to it. You don't want to add a new line. You don't want to do something like add a new line to it. So I'm just gonna say do nothing, right? And then at the end of every row, once you're done doing that, just print nothing as well. And the reason for that is because if you don't do that, then it's gonna try to do a new line or whatever, and it's not gonna look nice. So we want to say that at the end of each one of them, when you're done printing, don't do anything. Don't add a new line, because then it's just gonna look, the flags are not gonna look compact anymore. They're just gonna have a empty blank line between each row. It's just not gonna look nice. And that's kind of it. And so we don't need the return statement because we're not returning anything. We just want to print. And we could go all the way back down here, and we don't need the print ASCII out anymore. Instead, what we're gonna do is we're gonna say take that and print symbols. So we're gonna say print symbols. That's what we created up there, and we're gonna pass it out ASCII out. ASCII out, right, like this. And let's take a look at all of this. We don't actually need this. This is just for illustration purposes. Let's save all of that. Let's get in here. Let's run that. Okay, let's take a look and see if this one matches our expectation. Okay, so this is the US map. What if we change that to the UK map? So UK, and let's run that. Okay, this is the UK map. All right, so it looks okay. Now, if you want to make the colors, if you want to add some colors to each one of the symbols, you can absolutely do that as well. And the way you do that is you basically, there is a, I have a video that talks about that. You can go to that video and watch that. But I'm just going to paste the link to you right now. So you can go to github.com, only phantom task 1. In there, let me just open that up for you. All right, so let me open that up for you. Copy this. So I have my browser open up. This is the URL. I actually have a video that talks about that. How do you add like some fancy colors to your terminal and stuff without using any dependencies, just using ASCII. So I won't have time to go into all of this, but I'll leave a link in the description if you're interested to check that out. But what we're going to do is to just find a color, and we're just going to copy that and paste that back in there. So for example, if you want to add some green color, you can just copy this chunk here. And so you're just going to copy that chunk. If you want to add a different color, feel free to go and copy a different color. And I'm just going to say copy. And then I'm going to bring it down. And say you want to have the color in here. So all you need to do is to add that, append that up front. So for example, 92M. And if you look at the colors itself, there are like the 92 give you that, 94 give you the blue. So if you want to change the blue, you can sort of change this to 494. But remember, you want to end them. So to end them, you want to look at what you have in the browser. What does it say here? It says that to reset them, you want to append the 0330M. So I want to copy that as well, and want to add that at the end of that as well. So that's kind of it. And if we save this, so this is how it looks like in all of that. So let's clear the screen now and let's run that again. Let's run that. So now you see that there's a like UK sort of the lines are actually colored in blue. All right, and you can try and play around with that figure. Let's say you want to play around with the pound sign, you want to change that, you could take that and add this, change this to pound, and here we change that to 92 m. Let's run that. Now you can see it get printed out like that. Okay, so the other thing I want to do as well is I don't want to actually hard code a image path here. So now I have UK. So what I want to do is I want to be able to allow the user to specify an argument, an extra argument to say that I want this, I want to ASCII this image or that image. So the way we do that is we're gonna go ahead and say import sys actually, because this is standard module, we want to bring that up, and then we could do it like this, right? So I like to basically bring up all the standard Python library, bring it all the way up the top, and then bring in the external dependencies, third-party dependencies down there. So now what we need to do is to change up the, we don't need the path to be like that. We could say something like, if the user, we specify an argument, so we can say ARGV. ARG basically says argument. So if the person call this script with a second argument, so if that equals to 2, meaning that's the second argument, then what we want to do is want to say path.sys.argv and take the second value of that. Okay, now just to show you what I mean by that, let me just print sys.argv. And let's save that. Now if I get in here, right? Now if I first run this, you will see that this is getting printed, but because I didn't specify a second argument, this did not execute. Therefore, there is nothing. The print doesn't get printed out at all because it doesn't even get executed. But if I run it with a second parameter, for example, if I run this and I run it with my assets, and I run it with North Korea, for example, and I hit enter, now North Korea is gonna get printed out, but I will also see that the print statement, because now the length will be 2. So length of 2 meaning that there are actually 2 arguments. So this is the first one, this is the second one. Now the first one is basically ascii.py, that's the name of the file, so that's nothing fancy here. So that's sys.argv0 would refer to this. But sys.argv2, that would refer to the second argument. So that would just be the path of that. And so this is what we're doing, right? This is what we're saying, is that if there's 2, then do that. If not, just default to uk.png. Or you can, if you don't want to do that, you can also say have something like else, and you can say something like print and say that ASCII takes exactly 2 argument. You can say something like ASCII, our script takes exactly 2 arguments. So please specify something, or actually takes exactly 1 argument, which is the path to the image. Path to the image. Okay, you can also do something like that. And then you would want to say something like exit1. So exit1 say that exit with an error. But you could probably do something like this as well, just bring it down. So it's up to you what you want to do here with your own script here, with your own script. If you want to basically throw an error and do a warning, you can do that. You can print a nice warning, or you can just say, okay, otherwise specify a fallback path. And I think let's go ahead and try a couple more values. Let's save that. Let's see. Now if we try Indonesia. Okay, Indonesia, it's just red and white, so really there's nothing. Japan. Okay, Japan is quite straightforward there. Korea, also pretty straightforward. But you start to see like, okay, most of the time it takes shape, and really all you need to do is to just change around the parameters there, change around the values. So what can you change here? You can change the symbols, you can make them, you know, slightly different color, you can give them a different look, change the different threshold if you want to. But I think that's about it. We kind of have what we need here. Let's maybe try, what about Texas? Texas looks like that. All right, that's cool. So you can go ahead and just try out different things. It's a pretty straightforward project, but it does expose you to OpenCV concepts, you know, taking images, converting them to something like an ND array, n-dimensional array, and then using them in place of these arrays, in place of these numbers, you actually replace them with some sort of threshold, and then if they miss the threshold, replace them with a certain symbol, and that's kind of it. It's a very simple project. The whole thing takes less than maybe 60 lines of code. If you don't include the import statements, maybe 50 lines of code. So I hope you enjoyed this part of the part 1 of this series. In part 2, we're still going to be using OpenCV, but we're going to build some other mini projects. For each one of the following video, we're just going to try and find some new cool projects we can implement using OpenCV, and keep the theory relatively light and just focus on building some nice stuff. So I think that's a maybe more fun, a fun way to sort of get yourself exposed to computer vision and building some nice utility scripts, and hopefully improve your Python skills and coding skills in the same time. Alright, that's all I have time for today. If you enjoyed this video, please share on social media, tell a friend about it, consider subscribing if you haven't done so, and check out my other videos. I'll catch you soon.